Okay. These are the free response problems from the B-test. C-test problems will be very similar in terms of level of difficulty.
No, I'm fine. I don't want to.
Okay, so this is an equilibrium problem, and I solved this a couple different ways because I don't know if everybody necessarily knew, but if this were in the Earth's gravity, you're going to get a different answer than if it's out in space, right? So I solved it both ways. But it was kind of midstream, so if I marked it wrong and you got it right in 0G, just let me know. All right, so let's do this first as if there's no gravity, okay? So if this were out in space, ups equals downs and left equals right. So that means that this triangle, the horizontal here will have to equal T2. And the horizontal is 42 times the cosine of 35 degrees. I think you're all getting pretty good at that, at labeling the components. The vertical is 42 times the sine of 35 degrees. So in no gravity, the horizontal equation will be left equals right. So T sub 2 equals 42 times the cosine of 35 degrees. Now you can solve for T2 there, right? And vertically, ups will have to equal downs. So that means that T1 equals 42 times the sine of 35 degrees. So if you solve this as if it were out in space, the answers would be 34 and 24 newtons. So I would accept that. Little tiny bit different if it's in the Earth's gravity. So if it's in the Earth's gravity, then we have to add one more vector, and it's the weight. So the weight would be in newtons, and the conversion there is mass times the Earth's gravity. So horizontally, that won't change anything. So the horizontal will be the same. Horizontal will still be T2 equals 42 cosine 35. And vertical will be different, so T2 is the same, 34. Vertically, though, ups, T1, must equal downs, 42 sine 35, and 3 times 9.8. So when you add the weight, that's really all you're doing is adding the weight to what we already solved for. Then the answer for the vertical turns out to be 53 newtons. Okay? So I'll leave that up for a second. Any questions about that one? Go ahead, Zach.
Were you trying, when you set this problem, was it supposed to be with gravity?
Yeah, I thought I had mentioned it, but I don't think I mentioned it in every hour, and I can't remember which one I forgot. Maybe it was this hour. Did I say it's in the Earth's gravity? That's what I thought, but just saying it, sometimes you guys space out, or maybe you're like really focused on a problem that's aggravating you and you don't hear me. So if that's the case, that's fine. It's the same skill set, so it doesn't really matter to me. So either of these would be totally fine. Yeah, it's my fault if I forget to write it on the test, but I do get that sometimes announcing it just isn't enough, right? Okay. All righty, we ready to go on? Yes.
I'm kind of confused. Like, why can't you just do the 3 times 9.8? That's what I thought we always had to do.
If it's out in space, then that force wouldn't exist.
Oh, I thought
It is in the Earth's gravity. I just couldn't remember. Like 1 hour, I forgot to announce that, and then when I realized, I thought, well, maybe even if I did announce it, like, you just didn't hear me because you were so focused on what you, the task at hand,
Okay.
which is not a bad thing, right?
Yeah. I just got a different answer, so I'm trying to like.
Figure out what you did, okay.
Yeah.
All right, let's go on to the Happy College Freshman water balloon question. Christopher, would you close the door? Mrs. Militex is in rare and loud form today. Okay, so we have a Happy College Freshman that has a water balloon fight in the hall of their dorm. And the water balloon grazes the ceiling, which would be right here at the peak, right? So at the peak of flight, the water balloon is at 2.5 meters high, and they're launched at 8 meters per second. Okay? And we want to know at what angle do we set that water balloon launcher to make that happen, okay? So you're not given too much stuff here. The angle of the ceiling.
Yeah, I think it, what angle would a balloon graze the ceiling? So I tried to find that angle between.
So like the angle between the ceiling and the,
Yeah,
and this?
what angle will they graze the ceiling?
I can totally see how you would have read it that way, but I have no idea how to solve that. Do you know why it's so difficult to solve it?
Yeah, so that's why that problem.
Yeah, well, that angle changes, right? Right? No, but I mean, think about this. The angle grazes the ceiling, so when it hits the ceiling, it's like this. A little bit later, it's like this. A little bit later, it's like this. Look, do you agree? And that's why it was like, oh, how do I solve for that? The actual angle that it hits the ceiling, though, is a real number, and you don't have to do any math. Or the complement of that, or zero. Because it's tangent to the ceiling, right? At the very peak of flight, it's tangent. So if you, did either of you put zero?
No, but I.
Dang, I would have accepted that, full credit.
I didn't put the answer. That's actually.
Oh. No answer means zero?
Yes.
I think she might be right. Did you put anything like that?
Well, I mean, I solved for that angle first, and then I solved for the second.
Okay, all right. Show me your test. That's a legitimate, I could see how you could read it that way, absolutely. Did anybody else read it that way, or now you're just going to jump on that bandwagon? Right. Okay. It would have been better worded if I had said angle from the floor. Yeah. Or the launch angle. Did I say that? Launch of at what angle will the balloon? Yeah. Okay, let's solve this for realsies now. Okay, I'll take a look at the two of yours. So this is the only thing you were given, and we've got all those equations, right? What is that number? What does that represent? The height. So of all of the equations over here, where would we find that number? Say yes or no.
Yeah. No.
Good. Why not?
Horizontal.
A couple people said yes, and then I heard like, no. Oh, I can't believe you would think that. Yeah, that's horizontal, correct. Does that work?
Yeah.
And does that work? Okay, so which of these equations do you think would be easier to wrestle with?
Distance.
Yeah, what does this not have that we also don't know? Time, right, we don't know the time. Yeah, and you know something special about this? What's this? Yeah, it's the opposite of the initial velocity, but not at the peak of flight. What is this at the peak of flight? Zero. Zero is, I know, we love zeros, right? Okay, let's try it with zero. Actually, do it right now, I bet you'll solve for it. Okay, here's what we're doing. Final velocity at the peak of flight equals 2 times gravity times the height, which we know, plus initial velocity squared. So we said this is what at the peak? Zero vertically, right? So try that. See if you can solve for theta doing that. The answer is, just 'cause it'd be good to work your way toward the answer, the answer is 61 degrees. I'm gonna see if I can pause the recording and then